facing. Thanks, Rich. Researcher facing, systems facing, data facing, emerging centers, and then a new one is strategy and policy facing. For software facing people, there's a really robust group within the US RSC. So each of these, we kind of have an unconference format that we have everybody can come once a month to each of these different topic centered, or not topic centered, but more facing centered meetings, and learn a little bit of something instead of having to go maybe go attend a conference for a week or whatever and spend a lot of money. So that's our goal. Also within the Campus Research Computing Consortium, we have the working and interest groups that are listed there. And those are for people, if you have an interest, you have something that you might want to see taken care of within our community or investigated. You can join one of those groups and help make our RCD community, research computing and data community, more robust by having these sort of tools. We have the operations group, which is helps make this all run a little bit more smoothly. It's a great, and we're all volunteers, and but we all have the same passion to grow our research computing and data community of people. We do have the CARC, moving over to the next column, we have the CARC YouTube channel, which you can find all of our conference recordings or unconference recordings. So that's a good place to look. If you search for CARC on YouTube, everything is out there. You can, including this one, will be posted. And then there's a little bit more about the working and interest groups. So with that, if you wanted to stop sharing, and then Alex Feltus from Clemson is one of our steering committee members. We're always looking for additional steering committee members to help us form what our topics are and help us run these monthly calls. But Alex brought our guest to us. And so Alex, would you like to introduce Bryan and his group, and we can get started with the real meat of this.
Yeah, so I'll pass it on to Bryan. He's going to introduce himself, but I'm not exactly sure. I forgot how we got together, but I have the little bits of the complicated life that Bryan leads is absolutely amazing. He's a citizen of the earth, and I'm excited to hear what he has to say.
Okay.
Thanks.
Oh, there he is.
Yes, hi. I'm just launching my slides. I don't know if it's loading up yet. Thanks for that kind introduction, Alex. Nonetheless, I appreciate that. Can you see the deck?
Yep.
Cool. All right. So I was told we've got the full hour, but I am not an efficient presenter, so I'm only going to use about 20 minutes, which is still a lot. I have some colleagues that are going to share a bit about their actual sites as well. So thanks very much for the opportunity for me to share about the state of our project, and particularly the HPC state in Africa as far as our project goes. Just very briefly, a bit about me. So I started off as an HPC system administrator and a recipient of hardware from this project that I'm going to be talking about back in 2013 when I worked on the east coast of South Africa in a town called Durban. Then I moved in 2016 over to the Center for High Performance Computing in the Advanced Computer Engineering Lab, where I now lead the project that I'm talking about. The predecessor of the project actually moved over to TAC. And so it was a good opportunity to take that spot and so have a connection with TAC, who are very strongly connected to this project. Then during that time as well, I was an HPC user when I was doing my grad studies at Georgia Tech, and I actually studied through the online program, and there's a bit of influence there in some of the stuff that we've implemented for our projects, and I'll talk about that as well. But most importantly on this slide, I am Bryan with a Y. So when you introduce yourself and you say, hi, Bryan, it's not Bryan with an I, because I already have two. There's a bit of confusion there already in the chat we had earlier. I'm Bryan with a Y. So for anyone that's not familiar with South Africa, I'll give you a hint. It's a really practical name for a country. We're based at the south of Africa, and the arrow is pointing to the area where Cape Town is, which is where I'm based now. I took the big move from east to west, where the rugby rivalry is the strongest. So I'm living in the home of my arch rivals in the Western Cape. I am based at the Center for High Performance Computing, which is our national supercomputing facility. It's a 1 petaflop system. It was on the top 500. It debuted at, I think, 123rd on the top 500. It's naturally fallen off after a few years. Depending on the use case, it's generally still considered to be the largest HPC system in Africa, particularly available to open science research. We focus on 3 research communities, the first being the South African academic institutes and research facilities within our borders. Then we have the Southern African Development Community, which is abbreviated to SADC. So if you hear me say SADC, I'm talking about these countries on the green on the right. And then we also service the SKA partner countries, SKA being the Square Kilometer Array. I will talk a bit more about that in an upcoming slide, but those are the countries on the left. You will see there's some overlap between the SADC countries and SKA. Not all SADC countries are part of the SKA project, and not all SKA project sites are part of SADC. So going back now to about 2014, there was a problem that was identified in South Africa's context. The Square Kilometer Array is the largest radio astronomy telescope project in the world. And it's essentially a square kilometer of radio astronomy dishes that are merged together. And they can generate, at the time, they're expecting 2.5 petabits of data per second. And it's just ridiculously impractical to store that. It's pretty much like duplicating the storage of the, cloning the internet every single day. So they needed a way to process this in real time. So they recognized that we would need to have exascale type compute to actually resolve this issue back in 2014, or actually prior to 2014. And then the other challenge was in the South African context, we needed to develop HPC expertise in South Africa. But since SKA was part of the African group as well, with the primary hub in South Africa, but satellites in other regions of Africa, it was also an opportunity to develop expertise in Africa. So this is a catchphrase that I've come up with: supercomputers live fast and they retire young. So the question that was raised by our director, Dr. Happy Sitole of the Center for High Performance Computing back then was, what happens to these systems when they are retired? And we found that most of the EU systems, the US systems, typically are mothballed or they're recycled in some fashion. But generally speaking, are they still useful at that time that they get decommissioned? Because it seems that they retire very young, considering the investment in them. And the case here was when we looked at TAC's Ranger system, when they decommissioned Ranger in 2012 or after 2012, it was still ranked the 50th fastest system in the world. So yes, if you're looking just purely at performance, this is surely still useful. And in Africa, since we had this need for HPC compute and we didn't have access to the resources, our director spoke to Dan Stanzione of TAC, and they agreed that forgiveness trumps permission. So what we did is we took about 20 racks of the, I think it was about 82 racks for the full system. We took about 20 of them, put them on a ship, sailed them down to Cape Town, and then we figured out what to do from there. And by then it was too late to turn around. So we took these systems, multiple racks were distributed throughout South Africa internal borders, and some sites received 1 rack, some sites received 2. I was based at Durban at the time, so I was one of the first recipients of this hardware, and the goal was to develop human capital in HPC in my area. I was going to be the trainer. I had rudimentary experience with clusters, but nothing at the scale. And then obviously I trained a student cluster competition team, and it was ultimately also going to be used to support the SKA initiative in Africa. So the first stage of this deployment was the local South African sites, and we managed to get 5 sites involved. My colleagues from WITS are on the call. They're based in Joburg, and then there was some other partner sites in South Africa, and that was at 5, 2014. Jump ahead to 2017. By now we distributed, I joined in mid-2016. By now we'd distributed Ranger hardware to about 10 sites in Southern Africa and South Africa. So the SKA footprint was growing. Not all the sites had received hardware yet, but in 3 years, we managed to deploy 10 systems. And when I say deploy, it's not necessarily fully operational. In fact, that's something I'll talk about, but all the sites got their hardware. Then during that time, the pipeline for Ranger was running out. We recognized that there was more demand than we could supply resources for. So other institutions came on board. Cambridge University donated us some of their old systems that they were shutting down. We still had some Ranger. Then TAC promised us Stampede, which was the next generation system. And then we also took our decommissioned system preceding our top 500 machine, and we started taking those components as well. So this became, well, let me talk about the name. It could no longer be called the Ranger Project. And we saw every site having what was effectively the mid-tier HPC type compute in the ecosystem, where the Pinnacle is the top national facility, mid-tier is like your mid-range supercomputer, and then your desktop or workstation would be at the bottom of the pyramid. So then we merged all those separate ecosystems together to form what is called the Ecosystems Plural Project. Then we jump ahead now to current times, and we've now distributed systems to 33 sites throughout Africa. In fact, all the SKA partner sites, including West Africa with Ghana and East Africa with Kenya, have their systems now. We've also branched out beyond SKA. It's now the Southern African community as well. So you can see sites like Malawi have become involved as well. We have Angola and DRC are showing interest. So the distribution of the hardware is actually quite fair now across all the partner countries. Locally as well, we've grown from 5 to 16 sites within South Africa as well. And this is just a heat map. I'm going to talk a bit about the impact of this later, but this is my travel in the first 5 years of this project, all the different places I've had to go to. You can see I've spent a lot of time in the US and also in Europe. That's for attending conferences, training, taking a lot of my cohort along to these opportunities to meet international partners. And also I'm quite heavily engaged with EPCC, and I'll mention that later as well. So the, I suppose, flagship system right now, although it's pretty old now, and also we've depleted the supply, was Stampede, and that was still number 20 when it was shut down at TAC. So we had a really powerful set of components here. The benefit of the Stampede rack is that you could actually modularize it because it's using the Dell C8220 chassis, unlike Ranger, which is a Sun system, which is just one monolithic server rack. You couldn't break it down into smaller components. This allowed us with Stampede that we could customize for a site's actual purpose. Instead of dumping an entire rack now, we could send even a subsystem if there was a minor requirement that they couldn't have the resources to run a full rack. And there's a reason for that, why it's advantageous for us. And I'll talk about that as well. But just to talk about the scale of the project, it started with one person in 2014. And at the CHPC, we are about 34 staff. This project has 19 of that staff involved in it. My advanced computer engineering lab is all involved. Then we've got research support that support the users of these systems in the remote sites. It's part of our mandate to support the academic institutions, so they support them remotely. And they also advise the sites that are administering their own local systems on certain deployment methodology that might help with the research that they need to engage with. And of course, we've got operations, and we have some technical staff as well that are outside of the advanced computer engineering lab. Although our skills overlap, they're just part of a different division in the CHPC. So how it happens is probably the interesting thing. And I like to call this a cautionary tale for anyone inclined to deploy HPC systems all over the place. So I was asked to speak about best practices on this stuff before at SC. And I said, I can't, but I can talk about worst practices. And through a process of elimination, maybe one day we'll find something that sticks. So I can warn you what not to do. So the first lesson we learned was, if something is available for free, there's going to be someone to take it. And we learned that the hard way. So people in Africa couldn't even spell HPC, but when they heard one was free, they took it. And of course, at the start, we needed to get these things out. We needed to just distribute hardware. We never thought for a moment that the people asking had no idea what they were asking for. And we have a few sites that still to this day have not unboxed their machines because they realized once they got it, it wasn't able to install VMware. It didn't support Windows for what they needed, things like that. So, we learned very quickly If you offer it for free, they will come. So to mitigate that, early on, we started an evaluation process, just a simple form. It's the first gate on your journey to HPC. When you hit this point, you fill out a form, we evaluate the form. If you meet the basic criteria, like really basic stuff, it's also just to get people to think when they're filling out the form. If they meet these basic criteria, then at least we know they're through the first gate. Now we can start talking more seriously about actual depth to their motivation for getting this hardware. So with that in mind, our traditional model would be have the hardware ready in Cape Town. This is a subsystem. This is not a full rack. This was an adequate small purpose system that could be distributed to a small research institution. Then we would do a site assessment, normally on paper, but if we saw a few things that seemed a bit strange, or if they themselves were not convinced or convincing, we might arrange a visit. And that visit normally entailed not only the hardware inspection of the proposed data center and things like that, but actually engaging the community, engaging the users, engaging the leadership, meeting the sysadmins that are going to be tasked with running these systems, so we could get a much better idea than we could on a virtual call. You could sit over coffee and ask one or two comments, come through, and then you kind of pick up, at what stage these people are in their journey with this stuff. And then we would do a site deployment, and at the same time as the deployment, we do a site training. And we use OpenHPC now, and I'll explain why we moved to OpenHPC. Initially, we did everything in-house. In fact, when we started, OpenHPC wasn't even a thing. But we found managing your own in-house software stack is crazy enough, but then trying to deploy the software stack to multiple sites where they all discover unique ways of breaking it, it just became too much for us to manage. And so we moved on to OpenHPC. And if anyone doesn't know what that is, it's a universal software stack that's been developed by the community. Carl Schultz from Tech, I think, started it, and it's a huge user base. And as far as I know, several top 500s at some point. I remember seeing OpenHPC on top 500 systems. The credit doesn't go to me for the decision. Anton, who's on the call and we'll be talking later, from Namibia, was asking for help with OpenHPC well before we even thought about using it. So Anton gets the credit for moving our entire community over to OpenHPC. But I mean, it's not compulsory. It's just there to make sure that we can all have a standardized software stack. So it helps the community to grow without us fiddling with all these nuanced systems where we can't actually help each other. It's all entirely voluntary. They can do whatever they want though. So then the second lesson we learned was about phishing and training. So we would typically go on site, and this is pre-COVID, and we could train a site at a time, and hands-on labs, things like that. And we could maybe achieve 4 or 5 sites a year. You saw my heat map with travel. I mean, it was me and one other person most of the time. Took a big hit on our families, and it was just practically not possible to do more than that. And if you do the math, 7 years of doing this at 4 or 5 sites, that's 35 potentially, and we only have 33 sites that are deployed, not a problem, except when it comes to the phishing. So you've all heard the expression that when you give a man a fish, you feed them for a day, and you teach them to fish, you feed them for a lifetime. The problem we discovered was if we teach someone to fish, they go off and fish in other people's ponds. And what I mean by that is we've got a guy in Zambia, for example, and this is just an anecdote, it's not a true event. They've suddenly developed some HPC skills, and Amazon will reach out to them and say, hey, do you want to come to Cape Town? You're just up the road, you've got the skills, we can offer you a salary that's very attractive for someone from Zambia, and you get to live in Cape Town. And that was what happened. We had people move from all these institutions to get better jobs. And that's not a loss, because that was one of our goals, to train expertise in HPC. But half of them didn't keep it in HPC. They went into enterprise cloud and things like that, so we lost them. And then the other side of it is that we had to train new people up. And as you can see, Oprah, you get a job, you all get a job. That was kind of a good problem to have, but it was a frustrating problem. And this was just not sustainable, because we kept losing people as soon as we trained them. So we moved on to a solution to that, which again, I keep promising things. I will get onto that. The third lesson we got out of this was typically a site that's asking for hardware is motivated for it. Outside of the square kilometer array now, they're motivated for it because they have users that need it. So we normally had research staff or teaching staff ready for a resource, but we still had to wait for the site to get ready to receive the hardware. We had to have the hardware deployed. We had to train the administrators to then run the system before these users could even get started. And one of the biggest problems was once the hardware laid on the ground in the data center, we had a huge lead time to train the sysadmins only at that point, because that was our typical model: show up on site and then do the training. So the question became pretty obvious: why do we have to wait for this deployment to conclude before we even start training the sysadmins? We need to keep the momentum going the moment the site puts their hand up and once the whole journey starts. And that's where we moved. Again, I'm getting to it. We moved to our current solution. The fourth lesson we learned was the sum of all the parts. At the beginning, it was one or two of us that did most of the training, and we were the experts in the software stack and things like that. But with my heat map of travel, I was never home. So when someone from one of the partner countries had a problem and they tried to reach out to me, they wouldn't get a reply. So we needed to find a sustainable model, because if a meteorite lands in the CHPC or Elon Musk's Starlinks decide to go home and they land in Cape Town and destroy our center and all the staff die, we don't want this project to collapse. So we needed to make this a community-driven project, and that we are just effectively community managers. So we embrace this community now. And we have a virtual community. We have the Google group, which was the first thing I set up when I joined and took over the project. It's a forum, it's a mailing list. It's more of a mailing list now than anything else. But we have 168 members from countries even beyond African borders. We post announcements and events there. Occasionally people ask for help, but the main platform now is our Slack, which is this one down here. And we have people from US and Europe on there as well. And we have a spin-off Google group as well, but it's linked to an SC group that we started for communities of practice and education. And I will be passing over to my non-virtual community members in a minute. Well, not in a minute, probably in 10. So I just wanted to give you a lay of the land of where they are from when they share their bits on what they're doing with their sites. So all Southern Africa, but there's a guy from Mozambique, a guy from Johannesburg, and then someone from Namibia. So now I'm getting on to what I said I'd talk about earlier. When we found the unsustainable training model with the physical insight training, we decided very early to move on to online training. It was about my third year in there, I realized we can't keep this up. It just happened to coincide that we developed this training when COVID hit. So I think a lot of people recognized the value in it much more than we initially thought they would. A lot of what I did with this development of this program actually coincided with my personal experience at Georgia Tech. It's not a great model to say, repeat what I like for everyone else, but it was the only model I had. And I happened to develop it as part of my research project for my master's in I did a module in educational technology, and that's actually a lot of literature review went into it, and I developed what I thought was a well thought out product. So we've created this online training for virtual labs in Open HPC and system administrators, the training workshops. So I won't go into the details here, but I mean, the motivation for online training was far beyond the COVID side. It would lower our overhead and our cost for traveling to all these sites. We wouldn't have the logistics anymore, or the workload that is associated with all these repetitive training sessions that we have to travel to all the time. We could also scale out, because now we could actually accommodate a much larger cohort in one training session than us going to one site and training 5 people or 10 people at a time. And we could even run multiple tracks at the same time. We didn't have to wait for one workshop to finish before we started the next. Principles that we adopted from an African perspective with resource constraints, this is quite important for us. I mean, even South Africa, we don't have electricity 24 hours a day. And it's not because we're a bad country, it's just because we have bad people that did bad things that manage the electricity. But you know, we drop our internet cables, undersea cables are down at the moment again, so our internet's down. Electricity goes off all over the country and in the continent. So we needed stuff that was accessible for people. Closed captions was important, not really for the hearing impaired, but because we could actually use it as a translating tool, because some of the partner countries speak Portuguese or they speak French. So for us, we can't train in Portuguese or French. We needed translators. Now we can make resources online that are digital that can automatically translate into a caption system in the language of the audience. Yeah, and we're talking about compatibility, multiple devices, user-friendly, replayability. That's important because not everyone is available all the time to attend the sessions, but they need to be able to play them back in their own time. We recognize the challenges, you know, with dropout and online. Things can get confusing. You've got a new topic that you're learning, but you're doing it in a new platform as well. That can be intimidating. But with everything, we just try to be human about this. we tried to make sure everything was manageable. So we focused on a training platform that was standalone, on demand, and could be fully run offline. And typically when you train in HPC, most of the time, it's using a cloud resource. And normally that gets associated with time delays setting up accounts, someone can't connect. And when you finish your training, at some point, your resource gets destroyed. And that's not practical. And especially in Africa, having unreliable internet, slow internet, or not even having a site that can host the resources to run a cloud, we needed a different way of doing this. So what we did is we implemented what at the time, and I have research to back this up, it was the first open HPC virtual HPC lab available. Prior to this, all the research I could find indicated that the only formal open HPC training was done at a half-day tutorial at one of these international training events, like at SC or ISC or PERC. And of course, for anyone in Africa, that's a really unattainable goal to go to these conferences in the first place. The capacity is limited, and for only running one a year for half a day, a lot of people will say you don't need this. The Open HPC guide is great, and I agree it is, but it assumes a certain level of competence going in, and that's not what we're dealing with our cohort. And then even so, all the labs that were hosted were done on cloud. So once the workshops were done, by the time half of my African cohort would come back to South Africa or Africa, it'd be a week later after recovering from jet lag, and sometimes the cloud resources were destroyed anyway, so they couldn't continue. So we do it all with virtual HPC using an offline, on-demand, standalone approach. You can download it, and you can do it in your own pace. And we have YouTube videos as well that complement the material. I don't need to really go into this except the fact that it's all on YouTube, and YouTube does the wonderful job of closed captioning in foreign languages. So we have Portuguese and French available, and it's some institutions allow zero-rated downloading of YouTube in Africa, so they can get the resources very lightweight. You can download the video like 4 or 5 megs a chapter, and it's done. And we follow the model of making small morsels, so you can do it in the small buckets of time that you have in your life. And then the virtual lab is run on VirtualBox using Vagrant to ensure consistency. We host it on GitLab, and again, can all be run offline. So that's the idea. We actually had a situation where someone actually used their virtual machine that they ran on their laptop, because these are all spec to run on your personal laptop. You run a 3-node virtual cluster on your laptop. They actually used that final product to manage their physical infrastructure that we delivered to them. So they're running their physical HPC system using a virtual machine developed on this platform. And then we run workshops that are formal, where we do them once a quarter. And we have a cohort from around the world, and they can all participate together. It's a 2-week session, but it's about 15 hours of work for our virtual labs. If you put it all together, it takes about 15 hours, but we spread it out over 2 weeks. And we have a forum for people to share ideas and things like that. The last training we ran was 70 participants. And in fact, it's not a big number, but the fact that the US showed up shows that it's getting attention. We didn't do a survey, so I don't know if the US guys found it helpful. And I mean, we need to be self-aware, but at least, 70 people in a workshop across the whole continent is much more than we could ever have expected to do in 1 year anyway. So importantly, we recognize we can't do this all ourselves. We need feedback from our users, and that's what we try to do to refine our product all the time. Just a bit of shameless plugging. We've won 2 HBC Wire Awards, which is fantastic. We received the Reader's Choice Award for Workforce Diversity Leadership in 2018. And then last year at SC, we won the Editor's Choice Award. But what was really cool was this is our co-located workshop with members from the US, led by Elizabeth Leak of STEMtrek. And Elizabeth won the Reader's Choice version of the same award. So our group won both Workforce Diversity and Inclusivity Leadership Awards. So that was pretty cool. Just very quickly on our current work, we're currently rolling out Open HPC 2 Virtual Lab, and we're launching our first workshop in September. We're also working on Open on Demand as a bolt-on to our underlying Open HPC virtual cluster. So you download the cluster, you don't even have to reconfigure it. We're going to provide the VMs you can just download and run, and then you can practice installing Open on Demand and playing around with that. We have a co-located workshop, like I mentioned, with SC22. We're doing one now in Denver this year, and we've submitted a few non-technical papers and posters for best practices in HPC education and training for SC23. So it's just to share about our approach, where we think get your head out of the cloud, work on doing things offline, because not everyone has access to cloud, and cloud itself can also break. We're going to be working on some things for next year. The main one is we're trying to work with the global HPC Certification Forum to get our training certified on the international platform, which if you're not aware of it, there's a certification forum for HPC skills that is being developed. It's ongoing. And then of course, I'll be doing some more site deployments. There's a link I'm just including here because I don't know if we upload the slides, but there are links to join the community if you feel that way inclined. And I listed some opportunities to get involved or how we would like to get involved. But of course, that would be a bit disingenuous because I should really let my colleagues that are sharing for their sites say how they think they could get help and what their pain points are. So in closing, I just want to thank my team, the community, TAC for all their hard work supplying us hardware, all the others like University of Cambridge and STEMTrek, EPCC and Prace, Open HPC, and also CARC for giving us the opportunity. So with that, I say thank you, and I'll hand over to my colleagues. I don't know if there's an order, but Anton and Shun, and I think Bernie, who might not be on the call, but those are the three that we're going to talk. So I don't know if any one of them is ready.
Great, thanks, Brian. I just in between, we'll wait, hold questions maybe for after everybody so we can make sure we hear from you guys. But I just want to say our community is full of a lot of individuals that are starting their centers, and they're one person. And I love, your story to me says, reminds us all that one person can start something and make it into something amazing. So, I always tell my staff, we're the heroes we've been waiting for. Like, we got to get out there and do this stuff because nobody else is going to do it. So congratulations to what you've done. And I'm really interested to hear everything else. And so let's continue on. Whoever wants to be next.
Okay, I'll go for it.
Yes, great.
Thanks.
And we will share your slides with the group if you don't mind. If you guys are okay with that, we'll post them in this call doc that we have, and then we'll also send an email out with them.
Thank you so much. Just to confirm, can you see my slides?
No, I cannot see them.
Okay.
We can see you now,
Thank you.
which is very nice.
Does that work?
No,
Okay. Sorry about this. Just
no,
gonna
no
take this out.
problem.
And now?
No.
Shun, do you want me to try to share the PDFs?
Yes, if that'll be possible.
Cool. Maybe Bernie or Anton could go next while I just download your PDF to get it ready.
Very good.
Okay, let me.
Hi. Okay.
Yeah.
Oh, Benny, it's fine. You can go for it. I'll go after you. Oh,
Anton, if you're ready, perhaps
you
you
can
should
start.
go while I orientate myself. Would that be possible?
Yeah, Anton, did you want to go ahead and go?
okay. Let me go for it.
Thanks, Anton.
Can you see my
Yes.
screen?
Yes, we can.
Thank you. Unfortunately, I'll not be able to share my video. We are shifting to spring, so I've had a bit of an allergic reaction because of the wind.
Oh,
Okay. So my name is Anton. I'm from the University of Namibia, which is one of the sites that received the equipment that Brian spoke of. So I'm just going to give a little bit of a brief and background of what we have in Namibia. So Namibia received a total of 4 racks up to date. through from the CHPC through our National Commission on Research and Technology. So the first two racks that we got were from the Ranger system, and the other two were from the Stampede system that Bryan spoke about. So the racks are split between the two universities in Namibia, which is the University of Namibia, the one I work for, as well as the Namibian University of Science and Technology. Both institutions have also been given a Dell T430 server, which serves as the manager node as well as the storage node. In 2020, because of the equipment that we received from CHPC, we also received 10 more computing nodes and 8 storage nodes from the high energy stereoscope system, or HACE, which is part of the, I think, SKA partner sites. So that has essentially helped us to bolster out our equipment. So the journey with our journey, we started off training in 2017, and during that time, Bryan and the team were still kind enough to actually do physical site visits. So they trained us in HPC system administration in Namibia. Then we also had the follow-up visit at WITS within the same year. I should also mention that in the same year, I also got the privilege to attend supercomputing 2017 in Denver, which was quite amazing. Then, of course, we still had further trainings that happened afterwards, and this is one of the pictures that we took in 2018 at the CHPC conference in Cape Town. This is just a couple of pictures from our data center. So we see the Ranger on the left-hand side. Then we have the Stampede in the middle. Then the equipment that we got from HES on the right hand side, as well as some news coverage that we got within the UNAM forum when we received the second supercomputer, which is the Stampede. So the current status, we're now running the Stampede as the main rack, as well as the 10 nodes that we got from HES. We then upgraded our storage on the T430 servers that we got. We were fortunate enough to also collaborate with people from meteorological services from South Africa, as well as the Namibian meteorological services. And through that collaboration, we awarded a grant, of which we got more storage that we added to our existing server. We then also got the equipment we got from HES came with some storage servers that we then decided to set up a distributed storage server for them because of the amount of data that they were generating. So we now have a 200 terabyte storage, distributed storage server alongside that. This then freed up our Rangers rack, which we are used mostly for training, especially for students. We use the Ranger rack for students as well as other workshops that we host. We also have done a couple of noteworthy projects. The first one was the land degradation assessment baseline report. This was done to essentially just assess how the soil has lost value in the northern regions of Namibia, and this was sponsored by GIZ. And then we also have done a couple of modeling of broadband emissions of globular clusters. This was done by people working on with the HES telescopes in conjunction with some researchers with UNAM. And then, of course, we've also done case study weather modeling, which was part of the grant that we received that I spoke about earlier. And of course, future prospects for Namibia as a team, I think we're still hoping for more trainings, and we are also actively involved within Bryan's trainings that is offering, the online trainings that is offering, and we've also been contributing to that. And we'd also love to see a little bit more support and collaboration, and possibly a couple of more hardware. Will be great to just essentially just bolster the current hardware that we have now at UNAM. That's it. Just made it short because Bryan already mentioned a lot regarding the project. Thank you.
Yes, thank you, Anton, for that information. Did you say how many staff you have in your center or on the two groups that you're working with?
Yes, so mostly the composition that we have at UNAM is I'm a lecturing staff, so I just add on as a HPC system administrator. So currently we have about 3 lecturing staff who are helping out in administering, but the other 2 are mostly physics lecturers, so they normally just cater for the physics sort of physics support group. Then we also have 2 more, I think I wouldn't like to call them staff because they are still currently students, so they assist in mostly in the day-to-day running of the HPC.
Okay, great. Sounds familiar. Okay, who do we have next?
I'll load up Shun's. I've got them loaded.
Hi, everyone. Hello. Hi,
Hello.
everyone.
Yep, we can hear you and see your
Thank you.
slides.
Hold on,
Okay.
Bernie. I'm doing Shun's slides.
Okay. Okay, the first slides. Okay, you can see my slides.
No, I'm doing the other slides now. Can you wait a sec?
Okay. All right.
Obrigado.
Okay, not problem. Yeah.
Shun, are you good to go?
Thank you so much, Brian. Thank you, everybody, for allowing us to join this meeting and tell you a bit more about the Ecosystems project and the difference it's made at Wits University. Brian, next slide, please. So Wits University has a small but proud history in high-performance computing, the start of which was a lot of material science work done on a small cluster in the School of Physics. That was a long time ago, but HPC, as we know, it only really started with our Professor Scott Hazelhurst and his work in bioinformatics in the early 2000s. Next slide, please, Brian. Okay, so the current HPC landscape at our university is a federated model. We have 3 small HPC systems. The first one is called the Wits Core Cluster, and it's largely used for what we refer to as big science, high impact science that involves a lot of money and a lot of key players from around the world. This cluster is part of the CERN project, but on the side, it also does a lot of work in medicine and bioinformatics. In our engineering school, we have another small cluster called Crunchyard that addresses some work with commercial users, and there's some interesting work that they're doing there in terms of user interface. And then the final one is the cluster that we call MS cluster, which is Stampede. And we use this for teaching. We use this for teaching our 4th year students and for research at the master's and PhD level. What's really interesting about this system is that it's largely student driven. Next slide, please, Brian. So some milestones that got Wits on track with HPC are 2 PhDs. The first was Dr. Renier Dreyer. His work led to the development of the Crunchyard, which was one of our small HPC systems. The second was Dr. Hairang Bao. Her PhD led to the development of 4th and 3rd year courses in HPC. So HPC is now a topic that we teach regularly at our university. We had a very important cultural breakthrough moment when Wits won an international HPC competition with the help of the CHPC. A very big milestone was the donations of the Ranger and Stampede racks, which I'll refer to again. Next slide, please, Brian. Technical milestones that helped us get going was the formation of a formal data science program. There was a conference called the Deep Learning in Dava, the first of which was held at Wits. That was a big eye-opener for all of us. I think the really big thing that got us on track was changing our idea of HPC as it applied to our users. We thought that our users wanted to do very high fidelity models, which they tuned against these huge data sets. And it turns out we were wrong. What they actually wanted to do was use these large data sets to automate the mathematical modeling process. And the moment we made that mental shift, things started to move forward. And this shift was enabled largely by the Ranger and Stampede donations. Next slide, please, Bryan. Okay, so I just want to talk about the impact of the Center of High Performance Computing at WITS, and it's huge. Our interaction with them started a long time ago. In fact, they had a national conference in Cape Town. That was our first interaction with them, and they've been helping us ever since. Our biggest help comes from the ecosystems community. There's been tons of cultural and technical exchanges. And through this, the CHPC, every year we're involved in HPC student competitions. This has traditionally been around HPC alone, but this year moving forward, I believe they're including topics like cybersecurity and data science. And all of these engagements with the CHPC is being done with Ranger and Stampede hardware. Next slide, please, Bryan. Okay, so the first donation that we got from TAC was, and the ecosystems project was the Ranger hardware. And what Ranger really forced us to do was improve our infrastructure, particularly things like our electricity and our cooling and our networking. It also forced us to cope with equipment that was complex at a level that we hadn't seen before. The huge thing is that Ranger already forced us to rework our job descriptions, and for many of us, forced us to rethink our careers. There was quite a bit of research done on Ranger, particularly in maths of finance. There was some gravity work done as well, and some simulation work done in material physics. But not as much research as you'll see was done on Stampede, which came a few years later. Next slide, please, Bryan. This is just a picture of Ranger in one of our data centers. It's not switched on now. It's been since replaced with Stampede. Next slide, please. Yes, Stampede was the second donation that we got through the ecosystems project and tech. Stampede came equipped with Xeon Phi accelerator cards. And for the first year, we couldn't get our users to really gel with these cards. So we made the decision to pull out the Xeon Phi cards and replace them with NVIDIA GPUs. And that lit a wildfire. Immediately, there was huge demand for the Stampede system. A recent development with Stampede is that we've noticed that our users are writing code that's bottlenecked by disk I/O. So what we're currently doing with Stampede is using a portion of it as a distributed file system, which is new territory for us. Stampede's been really great. We've gotten tons of research done with it, and we reckon with a few spare parts, we could run our Stampede rack for at least another 5 years. Next slide, please, Bryan. Just some pictures of Stampede on the extreme left. You can see our Stampede rack. It's in a bit of a state, but completely working. The next two pictures show some modifications that we made to the Stampede rack. The first was taking the Xeon Phi cards out and installing these NVIDIA GPUs. And then the recent modification, which was, again, using that same space for some solid state drives that we use to build a distributed file system. Next slide, please. Just a few words about things that we may be doing a bit differently at WITS, sometimes for the better and sometimes for the worse. Things like student interest groups are given very, very high priority. In fact, we even give students involved in the activities their own office space. And it gives us good results. The other thing is that we're not part of a bigger project like CERN, which means we don't adhere to these to very strict rules, which gives us some freedom to break things. And we do break things very often, but we notice that when we do break things, we also learn a lot. So it's been really educational to not have to adhere to strict rules like compute clusters that are part of, say, the CERN framework. The other interesting thing about our team is that we're not strictly an HPC team. We do some other stuff as well. And that also maybe gives us a different perspective. The one thing being, because we're really busy with multiple things, we tend to not overcook our system. And I'll talk about that a bit in a few slides. The biggest thing, though, is that our Stampede rack is largely managed by students and maintained by students. And that's a big thing for us. Next slide, please. Okay, the way we deploy our systems is also a bit different. I know most of the members in our ecosystems community are using Open HPC. We've decided to go a slightly different route where we build a very minimalist system. We're not doing any network booting of any operating system. There's no complex user management. Even things like software maintenance is kept to a bare minimum, just using simple Ansible scripts. So as far as possible, we try to keep our system as lean and as minimalist as possible. And our experience is at the scale of about 1,000 users, which is what we have on Stampede at the moment, we don't really need to put too much of effort into best practices. It's much more important just to get users onto the system, get their runs going, and allow them to get their results as quickly as possible. Next slide, please, Bryan. Just a few words about our current configuration. We've noticed that you basically just need 4 things in our environment to cater for 90% of our users, and that's just Linux, Slurm, Kura, and Anaconda. And if you allow people to manage their own Anaconda environments, users pretty much take care of themselves. We've got MPI and OpenMP for coursework, and for organized groups, we've got some container support using Aptainer. There's a couple of users that use high-level languages like R, MATLAB, and Mathematica. But we've been able to get about 100,000 big jobs done per year. And that's across 1,000 users, and about 15% of those tend to be very heavy users that will be running a multi-node, multi-day jobs on a regular basis. Next slide, please, Bryan. So we do know that there's a lot of things that we're doing really badly compared to the rest of our community in the ecosystems project. We're not passing down the training that we receive to our users as effectively as we could. That's something we need to look at in the coming year. We're not really good at writing reports and documenting what type of science has been done on the Stampede system. We're also not very good at keeping in touch with the ecosystems community. In fact, we've only started using ticketing this year, which is a bit embarrassing to admit. And things like job accounting, which isn't really an issue yet, is certainly something we need to start paying a bit more attention to. And one thing we haven't spent much time on is security. But we've noticed even with 1,000 users a year, you probably only have about 2 or 3 security incidents. But I can imagine that there's potential for that to get worse, and we do need to spend some more time on security. Next slide, please, Bryan. So things that we want to look at in the next year, as I mentioned, we implemented this distributed file system. We want to just evaluate its performance to see if it's good enough for our users' needs, and if we need to look into something a bit more sophisticated like Lustre. Also, we're taking the Stampede rack and we're using some of the nodes for storage and some for compute, what the right balance between those two is, we're not quite sure, and we're going to have to figure that out through trial and error. Also, InfiniBand networking has become a huge issue for us, not because of MPI, surprisingly, but because of this high-performance storage that we need to offer our users. Next slide, please, Brian. Just a few words on the type of science that we're supporting currently and in the years to come. We're focusing a lot on robotics and the AI used for real-world robotics. So I know the rest of the world is dealing with AI in these virtual spaces. I think the AI we're looking at WITS is very much embedded AI inside real physical robots that move and engage in the real world. And that type of AI tends to be a bit different. There's different challenges there. And the things we're really interested in is how to avoid learning from scratch, which tends to be the default at the moment. It's really easy to learn from big data sets, but how do you learn from small data sets? Once robots have acquired knowledge and skills, how can you combine old knowledge and skills to solve novel, unseen problems? But overall, there's this big interest in AI in the physical world. We also have a few researchers that are looking specifically in problems in machine vision and artificial intelligence for the medical domain. Next slide, please, Brian. I'd like to spend some time just talking about what the ecosystem project has actually meant to us at WITS, because it's difficult to overemphasize how big a deal it's been for us. I mean, at a very shallow level, the first thing that it managed doing is creating buy-in in our community. But at a deeper level, like I said, the ecosystems project has affected job descriptions, and it's affected decisions that people have made for their careers, right? And I think that's pretty profound. We, as support staff, simply wouldn't have gotten the opportunity to, for example, travel to these conferences and talk to other support staff in places like the US and Europe if it weren't for the ecosystems project. We would have been very isolated if it wasn't for this project. This is a difficult one to admit, but the ecosystems project has actually taken us more seriously, sometimes more, taken us more seriously than our university sometimes has. And that's meant a lot. To be brutally honest, we're so grateful for Stampede because we simply wouldn't be able to afford to buy a host for 40 GPUs. The other big thing is, like I mentioned, our operation is largely student-driven, and we need to keep our students motivated. And Stampede and Ranger, over the years, have provided a huge source of pride, to keep our students engaged and keep our students interested in keeping these systems running. A few things that we're also thankful for is that the ecosystems has been very open-minded about WITS doing things a little bit differently. Things like allowing us to not use open HPC and basically roll our own. And that's come with some benefits. And also, if it wasn't for the ecosystems project, myself and none of my colleagues would have had the opportunity to work on machines as exotic as, say, Ranger. So we're really grateful for all the hardware and all the opportunities that the project has brought for us. Thanks a million. Thanks, Brian.
Terrific. Great information. We are running over a little bit, but we want to definitely hear from Bernie still, please. If you need to go to another meeting, we'll see you all next month. And actually, I will definitely be asking them back, probably joining with our other facings, so we can actually have kind of a more facilitated conversation. But that will be at a future session. So look for that and look for the recording, but we'll continue on. Bernie, would you like to go next? There we go.
Hi, everyone. Hello, you can.
You're a little bit low,
hear
Bernie.
me?
The sound is very low.
Okay. And now?
We can hear you, but
Hello?
I think it's okay.
And slide, you can see my slide?
Yes.
Okay, I can start now. Okay. Hi, everyone. My name is Bernie from Maputo, Mozambique. I am HPC administrator at Mozambique Research and Education Network. This network project currently runs under the National Institute of Government Electronic, and the HPC is one of the part of the MORNET strategic focus. Next slide. The MORNET HPC service started in 2018 through the establishment of partnership with the CHPC, Center for High Performance Computing for South Africa, where we received two clusters, Stampede and cluster C600 for to part of our HPC ecosystem project, and the SS and Square Kilometer Array African partners, and from that, MORNET set up as the HPC as one of the 6 strategic focus for Mozambican National Research and Education Network, where the strategic goals are the establishment of a center of HPC to provide hi, you can, hello, you can see my second slide?
Yes.
Okay. The strategist goals, establish a center of HPC to provide computing service for academic and research institutions in Mozambique country, and be facilitator for scientific research discovery aligned with sustainable development in our country, and also support scientific research in deploy codes, scientific codes and test simulations of phenomena of several scientific domain, and in parallel to work to support a Square Kilometer Array project development and modernization of meteorological and hydrological service, and to health and energy sector, which have a big challenge in Mozambique. The infrastructure deployment process, since we receive the ecosystems in resume. First, we had an workshop training about the Open HPC in Maputo, where the CHPC Bryan and the U team comes to Mozambique and training us in how to deploy the Open HPC cluster and set the physical hardware our cluster, and after that we forward to deploy this or to apply this knowledge in the Stampede as a Stampede in our data center to deploy this HPC system in Mozambique. And the hard work, the status of our hard way, that is our ecosystem are composed for two clusters. The first cluster is we called a lab card, a laboratory of HPC. This is in Portuguese. Cluster are composed for cluster C 1600 where we have five chassis and 4 nodes per chassis, and that nodes have 12 cores and totality 240 cores. And Stampede, we have in total 4 nodes and 960 cores are working now and that ecosystems are hosted at Malwana National Data Center in Maputo province in 60 kilometers forward in Maputo city. And the resources data resource capacity data available right now, there is a 12 compute nodes of Stampede, and we have 16 terabytes of shared storage, and and these compute nodes are communicated by the InfiniBand network, where he's performing simulations, and the cluster C600 are in deploying mode to be used as laboratory for applications, codecs, tests, training sessions, and to assist students and research community to in new research purposes. As you see here, there is one of the states when we access the hour clusters, there is a modules available on these several modules available on our HPC systems currently, and these ecosystems we are deployed the Open HPC software stacks with these specifications. We recently done migrate to Open HPC 2.6, where the operational systems as Rock Linux, and we have these management tools to provision our service, Wirewolf and Slarm to has our workload manager of resources, and these development tools, MPI, OpenP, and GNU compiler to deploy or to support to deploy our codes in our ecosystems, and scientific codes that are available in Resume at least is in this column. We have an NCL, in car command language, Python, and recently we deployed the WRF and the WRF Hydro to perform simulations to perform simulations of cyclones and atmospheric receipt proposals. And in our ecosystems to perform or to access these softwares or these scientific codes, we encourage the users to complete an HPC user form where he's fill or provide data such as your institutions, research plans, and codes of proposal of utilizations, and as staff I evaluated and provide assess the users and start to guide navigation through the clusters. And currently we have these users or active users from research and academia. Some users are assisted and as we consider it a PI, principal investigators, where he's assisting undergraduate and master students on field of oceanography, and use codes like MATLAB and Croco models. And we have Genito Mauri from Department of Physics of where I perform some simulations to climate modeling, and where I use WRF, Python, and open form, and these other users. One of them is from the National Institutes of Meteorology, where we assist on deploying and test the numerical models for weather prediction. And currently we have this in resume. We have these five or six active users in our resource, and some of results for these for these users I can you can see in these slides. And recently we did a benchmark simulation on Stampede, where we performed a cyclone, recent cyclone Fred, which affected in central of Mozambique, and we noted that we had a good performance of WRF on our cluster when we increase the compute nodes up to 10 compute nodes, and we have a less times to results for simulations of 6 days for cyclones, for cyclone Fred, with high resolution, with a 3 kilometer resolution for Mozambique domain. And in the other hand, we other staffs did the drift scan of Virgo way of radio astronomy data, and that is one of the results. And the other example of what we did recently, it's the solving of 3D time independent coordinated equations using a numerical method for different quantum systems, where we have these results of cautionary questions without several tests without parallelization and with MPI and some one of my colleague or my colleague Martilio did this experience on our clusters to use tests in physics. And what we did about the capacity to build capacity or workshop participation. Last year in October we did a first training for potential users in Maputo where we training our users what the HPC is and how to perform or how to access our clusters and how to switch codes, how to build the codes, and training about the Linux command for our potential users. And one of the staff was invited to participate on HPC numerical weather prediction, which occurred in Pretoria in last year. And also in November I was a part of this SADC HPC team in the International Conference of Supercomputing in Dallas. And the prospectus plans for next month or for next year, that there is to release an workshop with HPC, because since 2019 we didn't have any other workshop or another cooperation in training, and now we plan to release that workshop which we plan to abord topics such as cluster monitoring report tools, cybersecurity training, and OpenHPC to review with CHPC, and establish the strategies to promote the benefits in how to for our community in which needed the power of computing for perform huge jobs or projects in several areas of scientific, and we have also ambitions to set a project to develop capacity and create community of HPC in Mozambique, involving more actors, more stakeholders, and more partnership composite to technologists, researchers, academia, and the government sector to build it and consolidate and robust program of HPC, because we identified the lack, the main lacks starts from the how to in HPC, what HPC is, what HPC for in many of areas of development sustainable in Mozambique and ICT too, and propose and currently we are work on to propose topics and assist the dissertation for undergraduates and master students on atmospheric and climate modeling in using the HPC resources from Moronet. And the challenge and the acute challenge in our sector or in this area of HPC in Mozambique is to establishment a solid HPC users in community from academia and the research sector, due by specific training per research filed on Mozambique. So right now we have a small users of small researcher with know-how about the use computer resources to their projects, and our goals is to expand these resources for more researchers to work on new projects. On new projects such as bioinformatics, bioinformatics, chemistry, ICTs, and more. And we need to improve the staff capacity in management and the administration tools of HPC clusters, where we felt we need to more training about network configuration, user database, monitoring tools, and have metrics about the CPU usage, cybersecurity, account manage, and workload manage to improve our activities as HPC administrators in our ecosystems, and establish and our challenge is to establish and maintain a structured team of HPC able to respond to demand of supercomputing needs for our communities, and influence policy and influence to policy and decision makers to elevate these ICTs in Mozambique to national priorities, because the HPC in Mozambique is a new thing, and we felt many parts of many parts doesn't have any knowledge about these infrastructures. The parts of policies and make decisions, directors have a lack information for these infrastructures. And finally, we need to increase our board of cooperations and do more efforts and partnership establishment to increase our hardware capacities, such as storage, and we are keen to acquire any GPU clusters to be a part of our HPC ecosystem at Moronet. And yeah, it's all. Thank you very much for you.
Thank you, Bernie. That was great. It's interesting to me how we all have the same problems across here in the US and over. I know it's like, oh, we all need this. So I think one of our goals is, how do we create more people that know what we're doing, and how do we get these policies? Your last slide was a great snapshot of what I think we're all trying to do as a community. So thank you for everybody for staying on. I am going to go ahead and end this, but I promise you that we will be putting together a follow-up call to this, where we will be inviting our hardware hardware facing group and our data and researcher facing group and our strategy and policy, and maybe we'll split out into rooms and we can also all work together and find a way to help us all keep going on our little paths towards saving the world with HPC, right? So thank you, Alex. Thank you, Bryan, for coordinating. This has been really fascinating, as you can tell by the 25 or 26 people that stayed on an extra half an hour. So again, really appreciate it. And maybe we'll see you all at Supercomputing if you make it. I will be sending out the video when it happens, but I'm thinking maybe October we'll look to get together again and have a really good discussion and make some plans together. All right. Thank you, everyone. Bye-bye.
Bye.
Bye.
Go
Thank you.
Earth.
Thank you.
Go
Thank you.
Go humans. Go humans.
Bye. Thank you.